Sorry, apologies, it was muted earlier. Okay, yes, so I will be talking about detecting Magecart and other malicious scripts with the new WebOrion JavaScript malware detection engine, right? As Danny has introduced, I'm Kyle. I'm one of the engineers, software engineers working on this WebOrion products, right? So let's get started. Right, so you heard Matthias and Danny earlier. They told you about web defacement trends and what is happening in the, in the web defacement landscape, right? You saw earlier there are examples of some are very obvious, right? They deface the whole page. They want to show off that I'm a good hacker, right? Some people they want to, but there are also you've also heard of those like British Airways. These are very subtle. These are hidden, and so sometimes I just show this example. If you're not aware, this is from a game called Among Us, where you're trying to identify like who is the imposter hidden in this crew of people, right? So it's a bit like this, you're trying to see what is suspicious happening on your page and trying to identify if there's anything unusual going on, and you can pinpoint that as a possible, hacking that's happening on your website, right? So this brings me to the point where what I want to discuss today, which is this thing called we call malicious scripts. Basically, it's like hidden scripts that hackers will put on websites, right, to do something bad, right? So like card skimming, cryptojacking, you have heard Danny and Matthias mentioned this earlier. And what our solution is, we have this WebOrion malware, JavaScript malware detection engine, right? So let's start on the main part. What's wrong with this picture? I'll give you a few moments to look at it, and you tell me if you see anything unusual with it. Any observations? Okay. What's actually happening is that the ATM works, but there's a fake pin pad on top of the pin, pin pad where you type in your pin number, right? And then there's a fake card reader that's installed on top of the real card reader. So this is where the term card skimming comes from. The criminals do this. They install this reader on top of the actual card reader, so that when you insert your ATM card in, this device will actually copy the ATM card and like skim the data off, right? And make a copy of the ATM card. So in this way, the hackers can then go and withdraw money from your bank account using the copied ATM card as well as your PIN number that you type in on their fake PIN pad, right? So this is what this is where the term card skimming comes from, right? Then, of course, when we talk about internet, there is no real card reader, there is no PIN pad. What is happening is that the hackers are trying to steal your credit card information, like credit card numbers, expiry date, all this kind of thing. So this is not a new thing, but it's increasing as you've heard from Matthias. It's really increasingly common attack nowadays. Just in October, there were 2 cases. There was this that were reported in the news. Of course, probably there are other cases, but these 2 cases were quite prominent. There was a US mobile operator, Boom Mobile. They had this card skimming script embedded on their website, right? So anybody who fill in their card when they try to check out on the website, their credit card information was stolen. There was this other, due to COVID, a lot of people are doing virtual conferencing. So there was this virtual conferencing platform where actually they allow people to create virtual conferences that they can sell. And they were also compromised by such a card skimming script, right? So in this case, I just want to highlight here, Matthias has mentioned the term Magecart, and we also use the term Magecart in this title. So the term Magecart comes from the idea of comes from this term called Magento. So Magento is actually a e-commerce platform, right? And in this case, this virtual conferencing platform, they use this Magento platform. So Magento plus shopping cart become Magecart. So Magecarts are basically this kind of attack where people put scripts onto the website to steal the credit card information as is being entered into the site. Of course, this leads to compromise of payment data, which, as we all know, is a concern, especially if you're an e-commerce company, right? You compromise your users' payment data is a very big deal. Next, I will talk about cryptojacking. So what is cryptojacking in summary, if you're not familiar? Cryptojacking is basically illegal cryptocurrency mining, right? And the whole concept of crypto mining is that in Cryptocurrencies, right, which you might have heard, includes Bitcoin, Ethereum, Monero, and this kind of cryptocurrencies. They don't have a central authority to verify your transactions, right? There's no bank, there's no MAS. So how they do is that they distribute this decision by using computing power to decide like which transaction is valid or not, right? And this requires a lot of computing power to run. And to facilitate this kind of computing power, they actually allow people who contribute their computing power to this whole cryptocurrency to do this mining, and then they can get they actually get this a bit of the cryptocurrency when they help to do this verification, right? So therefore, they're kind of like mining. They use their computer power to mine for this cryptocurrency, right? So that's what crypto mining is. And the hackers, of course, look at this and they're like, I also want the cryptocurrency, right? But if I run my computer, I will need to buy the hardware to help to contribute this computing power. I also need, run my electricity bill, right? It can be very expensive. So what they of course try to do is, if I can use other people's computers, other people's electricity to do this mining, wouldn't that be very good? And that is exactly what cryptojacking is, right? They tap on other people's computing power to mine these cryptocurrencies for them, for the hacker, without the permission of the computer's owner. Okay. So imagine it's something like this, right? This is my AWS bill for the month of November. Okay, imagine it's like $7.80, right? And then, maybe you go to, I go and sleep, and then tomorrow I wake up and I see, oh, my bill is now $78,000. Oh no, so okay, I just made this up, but this is not a theoretical scenario. In fact, in 2018, this is what happened to Tesla, the electric car company. Hackers actually managed to gain access to Tesla's cloud environment, and then they turn on VMs and containers in Tesla's cloud environment on Tesla's bill to mine cryptocurrencies, right? So before Tesla found out, they were actually paying for all these virtual machines and all these servers that they are not used. It's not actually used for their workload, but for the hackers to mine these cryptocurrencies, right? And you may have, John Matthias also shared earlier, I think that this cryptocurrency, cryptojacking, right, also can take place in the browser, right? And it was recently reported that browser-based cryptojacking has spiked 163% in Q2 of this year, right? And this is based on a trend landscape report by Symantec, where they actually mentioned that among their users, they blocked a 163% increase of cryptojacking events compared to a previous quarter. And they attribute this to increase in the value of these cryptocurrencies like Bitcoin and Monero. Right, so of course, now I guess you have better understanding of what is card skimming and what is cryptojacking. Right? So let's see how these kind of things, how these kind of malicious scripts work. Just like any other defacement, the hacker must first somehow find a way to gain access to the website and try to modify the website content, right? So in the case of a card skimming attack, the hacker gained access to the website in some way. They want to modify the content. Instead of changing the website and put their message with their hacked by KRDSec or something, they put a script on the page. And this script will collect the credit card information and send it to the hacker, right? So this script, once it's on the site, when the user, or anybody goes to the website, this script will be there. And then they try to fill in their credit card numbers, their expiry date, and their CVV or whatever, right? And it gets sent to the hacker server. So this is how this kind of JavaScript-based card skimming attacks work. So after this, the hacker will have a copy of this credit card information, and they can do whatever they want with it. They can sell it, or they can use it to buy expensive stuff, which they can then sell and then use it to convert to make money, right? So the other part would be, the other thing that you've heard, cryptojacking attacks can also be done with JavaScript, as I mentioned. Again, the hackers will have to find a way to gain access to the website and modify the web page content, but this time they put in a script, and this script does the crypto mining in the background, right? So whenever anybody visits the site, they will be running the crypto mining for the hacker, right? So when user visits the site, they have this script on the website itself, and then once the user loads this website and the website is running, the user's CPU will be, computer CPU will be used to mine the cryptocurrencies, right? And all these cryptocurrencies go to the hacker. So this is how the JavaScript-based cryptojacking attacks work. And this with these threats in mind, we want to share with you our JavaScript malware detection engine, which is the new engine we are introducing today, which you have heard from Matthias briefly mentioning earlier as well. How this JavaScript malware detection engine works is really quite simple. We have, in your site, if you are familiar with how websites work, you may have many JavaScript files. We take all these JavaScript files and we feed them through, we scan them and we feed them through a scanner that compares against signatures of known malicious JavaScript, right? So we have a set of known malicious JavaScript signatures. We check all your scripts against these signatures, and then we come back to a conclusion whether is it good or bad, whether we know that it's bad. So let me quickly show you a demo how this works. Let me switch my screen. Okay, so this is our new WebOrion portal. If you have not seen if you're not trying to log in, you can actually log in with your existing credentials if you're already our user, right? So this is how it looks. It's definitely much more modern. And if you notice here, we still have the engines that we previously had, the content integrity analytics and image analytics, but we have a new tab here called the JavaScript malware detection engine, right? So this engine is very easy to use. As just one checkbox. You want to use it, you just tick and you enable, right? So once you enable this engine, if you've tried to verify the site, okay, you can, let me show you what I have verified earlier, right? Okay, so you can see that with this new engine turned on, we have still have the 2 alerts from the content engine from our old content engine, and then we have this new JavaScript malware detection engine. It highlights to you that there's one thread, right? So you can see that with the content analytics engine, it tells you, oh, there's a new JavaScript added, right? There's one, previously it was 7, now it's 8. And also before this without this JavaScript malware detection engine, what our analysts, security analysts will previously have to do is they have to come and look at the HTML, which we actually do keep track. We have the differences, and they can see that, oh, okay, there's a script that's added. In this case, it's called example coin miner. And then, but of course, this is just an example. Perhaps their script, the name will be something that looks very similar to one of the scripts that you already have on your site, right? And then if you perhaps look at the script, you tell the security analyst will be able to say that, oh, so this one looks like it's a crypto mining script, right? This is what it does. It calls this Coin Hive, which was a quite famous crypto mining, browser-based crypto mining kind of like service. So you can see, oh, there's this script, so they know that this is a crypto miner, right? But this takes time to analyze and before you can conclude that this is the case, right? With our JavaScript malware detection engine, if we know that this is a known threat, if you look at the result, immediately tells you this is threat found, right? This is a Bitcoin miner. So you don't have to do if we know that it's malicious, we will tell you immediately, and you can reduce the amount of time you need to spend to analyze such a threat, and you can respond faster, right? So let's go back to the slides. Okay, this is what I've shown you earlier. Yes, so as I mentioned, right, the advantage of this JavaScript malware detection is that we feel that before that we need to actually have some analysts to look and understand the JavaScript before we can conclude whether is it malicious or not, right? With this JavaScript malware detection engine, if we know that it is malicious, it will immediately alert you in the email alerts. And therefore, you can prioritize this as a high importance alert, and you need to look at it more immediately, and you can improve your response time, right? Before you even ask for the analyst to look at it, you already know that it's bad. The other benefit of this JavaScript malware detection engine is that it's signature-based, right? So our other engines, if you are a current user, you probably know that we actually have a baseline process, intelligent baseline, which is like what we deem as what website we know it should be like, right? Whereas for this JavaScript malware detection engine, it does not require this baseline. Instead, we have this set of known malicious script signatures. And since there's less configuration needed, right? There's fewer false positives that can occur through this engine. As well, if you have pages that are very dynamic and they change all the time, which is very difficult to capture a proper baseline, this engine also works with that, right? So you can work with more web pages. So how do you sign up? You've heard you heard what's so good about this new engine, right? We want to let you know that if you're already our existing user, we're offering a free trial period until 28th of February, 2021 for this engine. So good news for you, you can go and try it out, and we'll enable it over the next few days for you, right? So do look out for it in the new portal. I do know that you need to log into the new portal in order to see this new option, right? And do also note that existing monitoring will not be affected. This new engine is an addition to the existing engines that we already have. So all the engines will continue to run at the same time. So I have an extra bonus section for you. We also want to talk about our upcoming engine, which we currently tentatively call the Dynamic Behavior Engine. Right. So the whole idea is that, I think you have heard that you've seen the examples of like British Airways, the crypto card scanning scripts. Generally, these malicious scripts have certain behavior that normally on the website, you don't see. For example, like they communicate with a hacker server or something like that. Right. So we want to see whether we can have an engine that can identify such behavior, right? We load the web page in the browser automatically and try to look at the behavior of the site, right? And then by looking at the behavior, we want to see whether the web page is doing anything suspicious, right? Anything unusual that is not normal for a website, for a normal website, right? So through this, we hope that we can identify suspicious behavior and identify malicious scripts as well. So this is near the end of the presentation. In summary, we have this new WebOrion engine called the JavaScript Malware Detection Engine. It is available for you to try, and we have a free trial until end of the month, end of February, right, 2021. So please do try our new engine. For our end users, we think that this engine will help you. It can help you to detect malicious scripts more quickly. This will improve your prioritization and your response time for this kind of threats. And it also works with your existing engines, so you don't have to be worried that your existing monitoring will not work. For our sales partners who are in the audience, right? We have mentioned about the new threats that are in the landscape today. So for these new threats, we have this new engine that we built to counter and detect these threats, right? And therefore, that's the reason why we built this new engine. Also, this new engine, it doesn't require using a baseline, so this potentially address new sets of customers, right? So potentially there's a larger set of websites and larger sets of customers that we can actually use our monitoring engine with. As well, we also take note, we have this upcoming behavior engine that I briefly mentioned. If your customers are interested, you can let us know and we can discuss further to let them try this behavior engine when it's available. And so now I've reached the time for the puzzle. These are the two last puzzle pieces, defacements number 3 and number 6. So now that these are the two two pieces out of the 6, so these are the last two, and please, you should have all the 6 pieces now. Please email the sentence as well as the numbers to jasmine@cloudsign.tech with your contact details to win the NAS audio. Right, so please submit this. I give you a few moments to submit this now because this is the last one, and the first person who submits it to Jasmine will win the NAS audio, right? So give you a few moments to submit now, and before we move on. So has everyone taken down their pieces and sent them over to Jasmine? Okay, so I understand some of you all have already submitted your puzzle pieces, right? So thank you for participating, and I still have a few more quiz prizes for you, right? Again, this is a $10 GrabFood gift card if you answer the questions correctly, and just type your answer in the chat like with the previous presentation. Right, so the first question: what are the two categories or types of JavaScript-based attacks on websites mentioned in this session? Right, this is multiple choice. There, you type in the two numbers that match right into the chat first to win the prize. Right, so the options are: 1. Ransomware, 2. Card skimming, 3. Cross-site scripting, 4. Injection, and 5. Cryptojacking. Okay, so we have a few different answers here. Interesting. The correct answer is 2 card skimming and 5 cryptojacking, right? I think the other topics were actually were not mentioned in this session. So although they are also JavaScript, they can also be JavaScript-based attacks, right? So thank you, Muifai, for participating. Your answer is correct. Okay, the next question: how does Magecart, or also we call card skimming, right, affect website users? The options are: 1. Mine cryptocurrency using the user CPU, 2. Steal users' credit card details, or 3. Infect the user's computer with malware. Yes, indeed, the correct answer is 2. Steal users' credit card details, right? So this is what card skimming is. Thank you, Adrian. Your answer is, you're the first one who got the answer correct. Just want to mention that, card skimming, why is it's called card skimming? Because, we are stealing the card details, right? And finally, what does the JavaScript malware detection engine do to detect malicious JavaScript? Right, the options are: 1. Check if the script is in the baseline of the web page. 2. Run the script to see if it has suspicious behavior. Or 3. Check the script against known malicious scripts. Right, so this is for the JavaScript malware detection engine. Okay, let me look at the answers. Okay, there's an answer from the first correct answer is I can see here is from Lionel, which is 3. Check the script against signatures of known malicious scripts, and indeed that is what our JavaScript malware detection engine does. Right. So for 1, check if the script is in the baseline of the web page. This is what our existing content and integrity engine does. And for 2, run the script to see if there's suspicious behavior. This is what our upcoming engine that we are going to we are still building, that we currently call the dynamic behavior engine. This is what it will try to do, right? So all these engines can be used together to try to detect malicious JavaScript, but they do it in different ways, right? Okay, so thank you for attending this session, and please try our new engine. It should be available for you to try in the next few days. And if you have any questions, you can post it in the Q&A section of the Zoom webinar. And next up, I'll pass the time over to Bridget